Mango Math presents Tsk Task, a pre-algebraic activity. Tsk Task is an algebraic activity that falls under the math strand of measurement, and it's an algebraic measurement activity where students use geometric approach to solve rate problems, and they'll use pattern blocks to solve those problems, and students will use the fractional or ratio amounts to solve them. The supplies that are provided in the pouch, along with your information sheet and directions, will be the game cards, the Tsk Task game cards, and then an assortment of pattern blocks. To start this activity, the students will draw a card, and on that card it will tell you the problem that they're doing. And this is Joe and Matt start a landscaping business together. Homes in the neighborhood have similar sized lawns. Typically, Joe can mow a lawn and trim all the shrubs in 3 hours. Matt usually needs 2 hours to do the same job. They decide to work together on 5 lawns. How long would it take them to finish? So we know that the math problem in here is we have 3 hours that Joe takes. Matt takes 2 hours. So we have Joe and Matt. Joe taking 1 hour with 1 lawn in 3 hours. So we have that set up. And Matt takes 2 hours to do 1 lawn. So we're looking at the bottom hours are marked there, and we have bars to show those, and we have the whole pattern box, the hexagon mark, to show a whole lawn. So that's kind of what it looks like right now that we know about. So we're dealing with 3 hours, so we want to break down the lawn into 3 parts for the one that takes 3 hours. So we're going to divide that whole into thirds. And then Matt took 2 hours to do the same job, so we're going to break up his amount that he can do into halves. And he can do a half in 1 hour and a half in another hour. So that breaks up how much they can do. Joe can do a third, Matt can do a half in 1 hour's time. So we have it written just like that on this sheet. Then we have to look at what can they do together. So they can do 1/3 and 1/2 together, and they can do that much over 6 hours, because each one of these brackets makes up 6 hours. So we're looking at this, and they can do 1/3 and 1/2 a lawn in 1 hour. And if I break this down more into fractional amounts I can understand, I can break this third into sixths and the halves into 6, and I now have 5/6 of a lawn I can do in 1 hour. The 2 of them can do in 1 hour. So we have that figured out, and we want to know for 5 lawns. So I can do 5 and a 6 in 1 hour, and I want to know how long it's going to take to do 5 lawns. So the pattern blocks on each bar represents how much of a lawn I can do in 1 hour. So we want 5 lawns. Well, right now I have 6 hours, and I have lawns that are 5/6 that fill up all 6 of those hours. So I want to see if I can break that lawn down into parts of 6. So I've broken it into 6, and now I can take each one of those 6ths and fill in the spaces for each lawn. And so now I have 5 full lawns completed, and it took me the 6 hours to finish it. Okay, to look at this mathematically, I'm going to write this down into the rate of work per hour. R equals rate of work per hour. Little j stands for Joe, little m stands for Matt. And so to find the rate of work for both of them, I have Rj plus Rm equals rate, the one rate. So I know that Rj worked, or the rate of Joe was 1/3 in an hour, and the rate of Matt was 1/2 of a lawn in an hour, which equals 5/6, because we already did that math with the pattern blocks. So my rate now equals 5/6. I want to know the work. The formula is work equals rate times time, or W equals R times T. And the work I needed to do was 5 lawns. And I did 1 lawn in 5/6 of an hour. So I need to have my time now to do 5 lawns. So to do that mathematics, I'm going to put my 5 over 1 to make it a fractional amount, because 5 over 1 is still equal to 5. And because I had to divide one side by 5/6 to get a 0, I now have 6/5 on times 5/6 equals 0. My other side is going to be 6/5 because I had to bring it over to the other side, which equals T, which is my time. And so I have then, if I multiply across, I have 5 times 6 is 30, 1 times 5 is 5, equals T, or I divide the 5 into the 30, gives me 6 equals time. So my time is 6 hours. So here's another example of doing the same type of activity. I have Maria and Dusty are decorating the gym with helium balloons. Maria can inflate and tie off 2 balloons every 3 minutes. Dusty requires 2 minutes to finish 1 balloon. Working together, how long will it take them to complete a batch of 35 balloons? So thinking about this the same way with the pattern blocks, we know that to do 2 balloons, Maria can do it in 3 minutes. So I've got 2 balloons for her. Dusty does 2 balloons, or 1 balloon in 2 minutes. So I have 1 balloon for him. I break that into our time, which is 3 minutes. So I have the bars to represent the time. So now I need to divide up the hours within those 3 minutes, or the hours. I need to divide the balloons up into those 3 minutes, how much they can do. So I'm going to divide into the 3, so I'm going to divide each balloon into thirds, and I'm going to divide the other balloon into halves because it took just 2 minutes, so I know how many I can do within a minute's time. So I break that all down, and I can do 2/3. Maria can do 2/3 of a balloon in a minute, and Dusty can do half a balloon in a minute. So now we need to figure out 2/3 plus 1/2, and what does that equal? And we'll see that if I divide it up into the 6th, it equals 1 1/6. So you can see I can fill in that one space with a little 6th mark, and I have 1 full one and then a little 6th there. Okay, so going on, I now need to figure out how many can I do with 35 balloons, for 35 balloons. But if you can see, I took out all those 1/6 and they make this little pile over to the side, and that makes 1 whole. So I can do 7 balloons in 6 minutes. All right, did you get that? I took all those little 6s, add them over here for another full balloon, and I've got now 7 balloons in the time span of 6 minutes. Okay, so from going on there, I still need to figure out 35 balloons. So if I take the 35 and divide it by the 7 that it took me to do in 6 minutes, I get 5, and then I do the 5 times 6 equals 30 minutes to complete all 35 balloons. All right, so you see how you can use pattern blocks to figure that out? So some guided questions to promote critical thinking. Did the model of the rate problems make it easier or harder to solve the problems? Why or why not? I'm trying to show how the time is broken up into minutes or hours. And what is the algebraic formula for solving for rate? And then they can come up with the W equals R times the rate times time. W equals the work equals R times T. And so those are the questions. They're very good questions to ask and get the kids thinking about how to solve rate problems.